Let's talk about linear motion. Here's an example of linear motion. I take this tennis ball and I throw it up and down. It's moving in one dimension, okay? That's a little different than parabolic motion, where it's moving at an angle and the force of gravity is also pulling it down. So let's first look at linear motion. Again, simply put, it's just change in distance over the change in time, okay? A problem you might see related to linear motion is a ball thrown straight up at 20 meters per second. For how long will that ball move up? And how high will it go? How far will it travel? Okay, to solve that, we need to think about it. So we're throwing the ball up at 20 meters per second, and it's going to go up until the velocity due to gravity is also 20 meters per second. So in other words, at the point at which its velocity due to gravity has equaled the velocity due to the initial velocity applied to the ball. Okay? Well, again, to solve that, let's look at a couple equations. Okay? First off, the distance traveled due to a simple velocity is just the velocity times time. So meters per second over seconds. Okay? The distance due to gravity is 1/2 gravity times time squared. That'll be useful for the second part here. Okay? And again, the force of gravity is 9.8 meters per second squared. And to solve problems like this, it's useful to simplify. So let's simplify that to 10 meters per second squared. That'll be close enough for our calculations here. Okay, so I want to know at what point will my initial velocity equal the velocity due to gravity. So my initial velocity is 20 meters per second. And I want to know at what point will that equal 10 meters per second squared times t. Okay? Pretty easy problem. If I see that 20 meters per second equals 10 meters per second times t, I can see that second squared, and this is going to be a unit in seconds, so they'll cancel. I can see that my t equals 2 seconds. Okay? So my ball's going to stay in the air for about 2 seconds, okay, before it starts to come down. Now if I'm asked how long will it remain in the air total, well, that's going to be 2 seconds up and 2 seconds down. Okay? So that answers part 1. Now let's look at number 2. How high will it go in the air? Okay? Well, now I want to figure out the distances. And again, distances for velocity is velocity times time. Distances due to the force of gravity is 1/2 gravity times time squared. Okay? So how do those two distances, because my velocity going up is going to start at 20, my velocity due to gravity is going to start at 0, and then it's going to slowly increase. It's going to continue to increase. So I'm going to add those two vector velocities together. Okay? So if I say, and for that one, remember the gravitational velocity is going to be a negative value, whereas my initial velocity up is going to be a positive value. Okay? So let's go ahead and calculate that. Velocity times time is 20 meters per second times 2 seconds. Okay? And minus gravity pulling it down, and again the distance due to gravity is 1/2 10 times 10 to the meters squared. That's the force of gravity times time squared, okay, which is 2 times 2. Okay, again, simplifying further, this is 40 meters per second times 2 seconds. Okay, so the seconds are going to cancel there, minus 1/2 times 10 times 2 squared. Okay, and again, to simplify that, 10 times 2 is 20, and 1/2 of that is, 2 squared is 4, so this is 40, and 1/2 of that is 20. So I've got 20 meters. Okay, so my answer here is the ball goes 20 meters in the air before it starts to descend.